Hi, good morning. This video is going to cover the basic of electromagnetic spectrum. The meaning of spectrum is basically a range of stuff. So what we have learned from our basic science is that our Earth actually receives energy emitted from the sun. And the energy is emitted and it is transferred to our Earth through waves. And that is what we have learned in the previous chapter, that wave is a phenomenon that enables energy to be transferred from one place to another. So why is it that we give this name electromagnetic spectrum is because the sun is actually emitting a range of wave towards our Earth. And why is it that we can categorize them under the same family name is because all these waves are actually traveling at the same speed. And you need to know this particular speed is 3.0 times 10 to the power of 8. So actually it is very, very fast, meaning within 1 second, it can actually move 30 million meters. So this is the speed of light, as many of our laymen has been calling it. You need to memorize this figure. It is a very important figure. So for our secondary syllabus, I think in JC as well, we will estimate this speed up to a precision of 1 dp. Okay, and because of that, actually the speed of these waves, okay, has the same speed 3.0 times 10 to the power of 8 in both air and in vacuum. So this estimation is good for both air and vacuum, and it is only good for these two medium. If it is in another different transparent medium like water or light or water or glass, then this speed will be different for the different waves in the electromagnetic spectrum. So like I said, spectrum means a range of stuff. So this electromagnetic spectrum consists of, I think, 8 or 7 different bands of wave. So why is it called band of wave? Because in the previous chapter, we have also learned that the speed of wave is given by the frequency times the wavelength. And since we know that for this particular spectrum of wave, they have the same velocity, it means that the frequency and the wavelength can change accordingly to give rise to the same speed. So let me illustrate this to you. So let's say I have V, F, and lambda. I have this 3 column. In order to have 3 times 10 to the power 8, I can have a frequency of 1 hertz, and then I have a wavelength of maybe 3.0 times 10 to the power 8 meter. I would have the same speed. Similarly, I can have the same speed if my frequency is higher, and so my wavelength can decrease, right? I will get back the same 3 times 10 to the power of 8 meter per second. So as you can see, because of that, I can actually have a wave that is of a very high frequency but a low wavelength. It still fits within the spectrum. And of course, I could have vice versa like this. Yeah, and so because of that, I would have a range of wave coming into Earth at different frequency and different wavelength, and they will arrive at our Earth at the same time because they travel at the same speed from the sun to our Earth. And because of the difference in terms of frequency and wavelength, they will behave differently and they will have different application. So for this chapter, we are only focusing on identifying, okay, or should I say listing down the different wave in terms of high frequency to low frequency or low wavelength to high wavelength in this spectrum. And within the different band of the spectrum, you need to know what is the name given to that band and its unique application. Okay, so how to memorize this? Wow, teacher, list so many things to remember already. How to remember? So down here, actually there are different ways of memorizing. There are some very elegant way, but I myself prefer a more down to earth and funny way to memorize it. So let me share with you. So for this particular sequence, I will remember it from high frequency band to the low frequency band. Okay, and they all belong to the same electromagnetic spectrum. And since I have memorized listing them down from high frequency to low frequency, in another word, it is also the same as listing down the wavebands from low wavelength to high wavelength. Okay, because they are inversely related. So down here, maybe I shift this nearer so that I have more space to work on. And then let's use the same arrow from low to high, right? Yeah. So the way I memorize it a bit crude, but it is very easy to remember. That is gorilla X urinate violently in my room. So I repeat, gorilla X urinate violently in my room. And what is this? Gorilla G actually stands for my gamma ray. X stands for X-ray. U stands for ultraviolet, not violent. And then V stands for visible light. It is important that you specify this as visible, because that is why we give the name to this special band of wave, because we can see. And then we would have infrared. Yes, infrared is actually outside the visible spectrum, the visible range. It means that you cannot see infrared. So sometimes when you go to the Pasar Malang, you will see people selling infrared laser pointer. That is actually marketing gimmick. If it is infrared, you won't be able to see, and it defeats the purpose of being a pointer. And then you would have microwave. So just take note, not all microwave can cook food. Some are being used as a telecommunication frequency. And of course, lastly, I would have my radio wave. Okay, so on your part, you need to go to the textbook, read up on each of these bands of wave and understand what is its application. So in this video, I will share with you some unique property of this wave that is not highlighted in the textbook. So what happened is that for high frequency wave, such as your gamma ray, okay, there is actually a physics principle behind. When the wave is having a high frequency, it is actually a dangerous wave. So why is this wave dangerous? Because at high frequency, it will carry energy and it can actually damage cells. So that's why it is dangerous. Now, so is it bad? Not really. If you damage cells that you do not want, then it can be a good thing, right? So for example, like cancer cell, you want to damage it. So you use high frequency wave such as gamma ray to actually damage the cancer cell so that it can be expelled by the body. Now another thing about high frequency wave that is not mentioned in your textbook is that it is highly directional. And it is good in this case because you want to be able to aim properly and at a small enough space so that you can just kill the cell that you don't want and you do not damage the healthy cell that is surrounding it. So having high frequency, it is actually directional. Now, why am I mentioning this? Is because for telecommunication, we are mainly using the lower bands of wave because we do not want a high frequency telecommunication wave. Imagine if you broadcast gamma ray. It's like bringing you out of our ozone layer and expose you to the sun's harmful radiation. That is gamma, and that will have a very bad effect on your body, right? All your cells will get damaged. So because of that, telecommunication frequency, we will always use the lower portion of the EM spectrum, that is your microwave and your radio wave. Now, you may ask me, teacher, then in order to be safe, why can't we just use the lowest of low frequency? Now that is because if you use low frequency wave for telecommunication, you would lose the you would not be so directional. So for example, like a radio wave, because it is used for broadcasting, you want it to spread, right? You want it to spread across a large area. So for example, your radio tower that broadcasts 98.7 frequency, that's basically your radio station name is basically the frequency that it is broadcasting. You want it to spread out, and when it is able to broadcast and spread out, you actually will not get blocked by your buildings like your HDB or your high-rise building and all that. Or for example, like in your at home, you want to broadcast the Wi-Fi frequency, you have rooms and walls and doors and whatnot. So because of that, you want it to spread out. So you do not want a highly directional wave. So that's why you would always choose the lower frequency band, your radio wave, for local broadcasting. Now what happens when you want to transmit signals to your satellite? Now because satellite is always moving, you do not want to have signal loss. So because of that, you would use a slightly higher frequency wavelength, slightly higher frequency wave, such as your microwave, for your satellite telecommunication, because it has this property of being more directional. So for satellite communication, you would use a slightly higher frequency wave. Okay. So another thing about these things that I can share with you that is not in the textbook is that for your visible light, you also need to know is color arrangement. So for me, I have very poor memory. So how do I memorize this is that since I know ultraviolet is out of the visible light and it is of higher frequency, then I will also know that, okay, my violet color should be the color that is having the highest frequency, and red would be the color that has the lowest frequency. Now because of that, it also explains for, I think blue is slightly below. So blue is actually a high frequency visible light, and it is very common, especially from electronic device. So like I said, high frequency wave are damaging to your cell. That's why you will have spectacle that has coating that bounce off or absorb the high frequency color. Okay, so I will stop here. Now what I need you to do is go back, make your own notes. There are many common properties across the different waves in the EM spectrum, and you need to know what are the common properties. Like I said, it is very important for you to take note that this particular speed, 3.0 times 10 to the power of 8, you need to memorize the value, and remember this speed is only good for air and vacuum. So for example, if you want to list down the common property of EM waves and you list the speed, please specify that this speed is only valid for air or vacuum. Okay, there are many different properties that you need to list down, and then you need to know the application for each of these waves that are in the spectrum G, X, U, V, I, M, and R. You need to know its application. Okay, I will go through the SLS exercise when school reopen, because I feel that if I can print it out for you all, you can actually take down notes rather than toggling between two different tabs or windows. So I will stop here. There's no holiday assignment, but I would check your file when school reopen, so you need to maintain your file. And that's it. Enjoy your May holiday. Okay, goodbye.